All right, so I wanted to mess with mainly the disk reading code, I think, for a bit. Make that a little bit better, abstract it a little bit, so that when we go to, let me actually bring this back up. I want to mess with the disk reading code because, well, I didn't do macOS, did I? When I go to the file browser, I want to be able to type something in here, like type in calculator, type in program 2, what have you, and then I want it to load this program I type in from this sector on the disk. So I want to change our disk read code to be able to just send it like a sector number and have it load it from the disk, say something basic like that. Sector number, maybe how many sectors to load as well, and depending on the size of the program, and then we can just load that. So I will work on that, I think, right now. So that'd be find file. We will go to, yeah, disk load. There we go. So this is just reading these sectors into memory. I'm not using this at the moment. So in my kernel, no, not in the kernel, in the boot sector, my mind is very good today. So I'm doing this. I'm doing read disk. I'm moving, you know, whichever disk I want to read. We're only reading one sector. File table is at sector 2, and the kernel, which is what we're doing here, starting at sector 3. Okay. But I basically want to put, this is called disk load, but I want to move, you know, this read disk code into disk load that we can call. The boot sector, I don't know, I might still leave that here, but at least for the kernel, I want it to load a separate thing. So, because if I wanted to use a separate source file here, the boot sector would have to refer to it, but the kernel would also have to refer to it. And I'm not sure how that would work in memory because they both be referencing the same file. I don't know if it would, you know, the source for this would then be in sector 1 and 3, and I don't know if it would try to read from a different sector or not. I guess I could test that, maybe off stream. Where am I loading files in here? Here, file table loop. Okay, so this will read it all out. Stop, this is where I print the message. So I need to get, say, the user typing something here. And I'm also gonna need to like search our file table that we print the screen. Well, search the area, which would be at 1000. So I also need to search basically the string we put here. And I think I can use scan for the assembly code, scan single byte or scan string byte, scan string word, something like that. I think that would work for this if I remember right. So I might try to do that. I basically want them to type in the name of the program. It scans, it finds this program, and then, you know, it skips that, it finds the sector, and then it'll call our disk reading function, whatever, and then load from that sector. And then I guess jump to it and load a program. So I want to do this so we load a program. I get experience doing that. And then eventually I want to make like an editor, source code editor, so I can save and write to locations on the disk. Then this thing can be self-sufficient. We can write programs and have it run programs that are written within the OS, and we can go from there. So that's my ultimate goal with this. Although I'm just spending a lot of time talking. That's okay. So how would we want them to type stuff in? We'll need to do get input, right? Like this stuff. So I want to basically copy this, I'm assuming. Get user input, print to screen, choose menu option, run command. So I could even put this into a separate thing, I believe. A separate source file. So we just need to do like this part here. Pretty much. But we need to save stuff inside. Well, I could use the command string. I don't know if I need another string to save what the user does in each of our like programs from the main menu here. I could probably just overwrite command string, repoint to it. So let me get this, get input and key. I'll call them different things, but let me get this code. I want to put that at the end of the file browser, into stop, instead of printing the go back message. Basically wanted to do this stuff. Don't want to get input. Instead of stop, let's call this something else. Jump equal, I don't know, get file name or something from user. Get program name. Where was I at? I was going from stop, right? Get program name. Let's call it get program name. So this is, okay, we're gonna get the keystroke. All right, we'll move it into there. I'm not gonna do run command. Oh, I guess I will if they press the enter key. I'll do something else. We'll do this as like file table end. We'll just do that. All right, so run command, I want to call something else. I don't know, run, well, if we're gonna load from the disk, I'll call it like load. We'll call it load program. Let's do that. Load program instead of run command. So if they entered in a valid program that's in the file table, we're gonna load it. Okay, and if they don't, I guess we'll have something jump the file table end down here if they don't load a valid program or if they want to go back. So we'll do that. Get the keystroke. If they press enter, go to here, or else we're gonna store the input character in DI, which is pointing to our command string. So I'm gonna want to search basically for the string they enter, such as calculator. So if they entered that in exactly, it should be in command string. So I want to search for command string inside of this area in the file table. So I would probably need to move this into DI. And then what they're searching for, I need to move into AL, which it is in AL, but still, I need to move it into like a whole string area. Okay, so let's move command string to maybe AX instead of DI, if that'll work. Let's see if this works. First off, symbol already defined, key loop. Okay, well this wasn't gonna work anyway, so key loop doesn't work. So get program name, program name loop. Very bad. That's all right. Program. Jump equal get program name, undefined symbol. It's right here. Uppercase N doesn't work. Basically, I need our command string to be pointing to AX, so I'll move whatever we enter, maybe DI here. I'll do this, move AX DI. If I can do that. I don't know if I can. Oh, that allows it, okay. So I'll do AX points to command string, all right. And then DI contains command string, so we need to move to DI, the area, 0x, because this is where our file table is. So DI points to file table, okay. I'm just making sure these work. Nope, extra characters on the line, can't do that. Can I do, I thought I did that in here before though. Did I not? Oh, ESBX is what I did. But at this point, ESBX should still point to the file table because I'm not messing with those at all. So let's do that. Let us do that instead. Because I did not mess with those. ESBX. All right. DI points to the file table now. So now we can do searching for the command string within our file table, which is scan SB. Well, which scans a byte at a time. To make sure we go left to right, we can clear the direction flag, but it should still be set to go left to right. Repeat not equal. Okay, so let's do repeat not equal. Although we need to get the length of the string. Crap. We need to get the length and put it into CX. Forgot about that. Hey, what would the length of our string be? So I need to use CX as the counter for our scan function, or our scan call, but I'm using CX already up here and it's being reset, and I need a way to store everything that the user does. Well, I'm doing that right here, right? Getting the keystroke. If they didn't press enter, I guess I'll increment CX here. Let's XOR, well, let's XOR it before we do this. Let's do it right here. All right, reset counter. All right, we're getting somewhere. Okay, now we can move, well, we can increment CX, I think. We can just do this. Increment CX. Oh, not there. Crap. Whenever they enter something in that isn't an enter, we can do this. Increment CX. Add to counter. Alright, so now CX should contain the length of our command string. So if they enter in calculator, it'll be, 8 or 9 or however long that string is, and that should be contained within CX. So because our scan decrements CX by 1 on each scan. If we're doing by byte, every byte that it scans will decrement CX by 1. So if we do repeat not equal, the way this guy on the internet did it, they have repeat not equal scan, and then they jump after this to say it's found. I guess we'll do this, jump equal found, Let me do this. Scan for string at AX in string, sorry for burping, in string at DI. Okay, so basically we're going to scan the command string, what they entered in, and you know, in our file table, which is now DI is pointing to. If everything is good and hunky-dory, I guess it'll be jump equal found. I guess. We need to end command string though, I think, with a null, right? So it doesn't search past that. We might do that. Because I have nulls at the bottom of these, right? A 0, yeah. So let's do that. So if they load the program, oh, let's move DI 0. I don't know why Emacs does that. I don't like that. Increments. So last character of command string equals null. So we stop searching for it. Okay. So let's do that. So jump equal found. Let's do found program. Hopefully I make this stuff look better in the future. Right now this is just making it work. This is not good code by any means. I'm not an assembly programmer by trade at all. So this means we found the program. Okay. Found the string. Otherwise we run this code. That'll be here. So we'll move into SI. Did not, I don't know. Not found string, say. Otherwise did not find program name and file table. Okay. And we'll call print string. Then what we could do, we could go back to get program name, I guess. We'll do jump, we'll get the next program name, I guess. We'll do that. Or we can go to the top, we can load the file table again, I guess. It doesn't matter. We could do that. We could load the whole thing again, which would be file browser. So we could go jump file browser. Let's do that. Lowercase b, okay. Reload file browser screen. Okay. But if we did find it, we'll go to found program. That'll be found the program. So that'll be good. I don't have a not found string. I guess I'll put that in. We'll put in a not found string down here. Not found string. This will be program not found. Try again. I don't know. I guess. Program not found, try again. And we'll just put a new line, doesn't really matter. I guess we'll put a new line here. Alright, we do want to get a keystroke though, I guess, because it'll print it and immediately go on at the moment, right? So I want to, yeah, move AH00 int. So they'll press any key and then it'll go back to the file browser. Okay. It'll reload the screen effectively. Okay, we'll do that. But if they do find the program, then we want to load the sector number, which sucks. How do we get the sector from that? We got to reload and go past it? I didn't think about that. We can just halt at the moment, doesn't really matter. Halt the CPU, which I think is HLT. This probably won't work. Oh, it did work. That's not good. No, I'm just kidding, that is good. So we can type stuff in. It says halt. It doesn't put the not found string to the screen, which is not great. That is okay. What if we do this? Then we'll have to mess with the boot sector again, won't we? Probably. Because we're loading more stuff. Alt-C. I just want to see if this works. No bootable device. Alright, good. Source, assembly, boot. I'm caps locking myself. That's nice. Let us read 3 sectors for the kernel. Okay. Why do I keep caps locking myself? That's not good. Alright. Alright, so... Nope, that wasn't the issue. It does halt, which is good, but it's not printing out our string, which is not good. That's not good. Whatever, I'll figure this out later. I gotta go to work, so I'm gonna cut back to where I continue this, hopefully seamlessly. And yeah, it'll all be good. Okay, it's been a little bit, but I got this working to how I liked it. I can show you this here. If we run box and go to the file browser, I got a thing, so you can type in one of these program names and it'll search what you type in through the file table. And if it's found, it'll say program found, and it'll go back. And if it's not found, it'll say it's not found. You can try again with a capital Y, or you can go back. So that's basically all I've done. It does not load the sector and does not load the program yet, but I got to this point, so I figured I'd record this. And for some reason I'm not feeling, I don't know. People at work have been sick, so hopefully I'm not getting sick. I'm just kind of tired. But then again, I think being an adult is just being tired all the time, right? So if my voice is fading a little fast, well, you'll know why. It's because I'm not feeling 100%, but that's all right. So I'll show you what I did. So I changed the file browser, right? Get program name goes down here. Added this. The user can input a program. We're going to print a new line here, just, moving hex A and D, printing it out. So the command string I'm setting to DI, destination index register, right? Then I also made a variable called command length, which is going to hold basically the length of what the user inputs. So it should be the length of command string after the user types it in and presses enter. And I added some more variables here. So debug test, I was debugging, so I just printed test whenever I wanted to see where a thing was at in the code. While it was running, I have a not found string. There's where the program's not found. Try again. Got that message. And here, see, we have command length. Just set it to 0 to start off for a counter of the length of the command string. I also changed success to be the program found message. I think that's all the changes down here. Okay. So we get the program name. So we initialize pretty much command length to 0 since it's only 1 byte. You have to give an operand, at least for this, in flat assembler. So move byte 0 into command length with the brackets. So program name loop. So we're going to get a keystroke, right? If the user presses enter, then we're going to search for what they typed in. But if they did not press enter and they're typing in, like you saw I typed in, the word calculator. If they're typing something in, we're going to get the next character that they did with int 16. We're going to increment command length, increment byte command length. So if it starts at 0, the first letter they enter in, this will be 1 because it's incrementing. It'll move that character that's in AL from this int 16. It'll move that into DI, the value at this memory location, which is pointing to command string. So the first character of command string will be AL, which has been moved into DI. Then we're going to increment DI to go to the next memory, the next byte of memory for command string so they can enter in, more characters for it. We're going to print out what they typed, and, we'll keep doing that until they enter in all they want to enter in. When they press the enter key, we'll go to start search here. I'm just going to reset DI to the start of command string, because after this, DI will be, pointing at the end of wherever the user entered. So if command string says calculator, DI would be pointing to R, so we need to set it to the beginning of the word so that we can compare it correctly. And then I'm XORing BX, so BX will be equal to 0 just to get to the start of the file table, because at this point, we've already printed the file table. BX would be pointing to the right bracket all the way at the end of the string. So we need to set a pointer back to the beginning of the file table string, and that's what that XOR does. If I can go back here, that's what this XOR does. We want it to, hex 1000, offset 0, so we reset the offset. So we're going to check a character loop here after we do that. I'm going to get whatever is the start of the file table, which will be the left bracket. It'd probably help if I pulled it up here, wouldn't it? Let's do that. Not print, assembly. So here's what it looks like. So the first character will be this left bracket, right? But basically, we're going to go through this and search for what the user entered. So the first one will be the left bracket. Compare it to the right bracket, which will be the end of the file table. If you reach the right bracket, then whatever the user entered, we did not find. So we go to program not found, which is down here. And that prints, the string that it wasn't found. It prints that out, and then it takes, you can enter in whatever key you want. And if you enter a Y, then it'll go back and reload the file browser and go back to this point. If they don't enter a Y, then it'll go to the regular end we already had, where it does the go back message, and you can go back to the main menu. But if they enter a Y to try again, it'll go back up here, so it'll reload everything and go back so you can enter another thing. I might have it go back here. I guess that'd be better than reloading everything, but oh well, this isn't performant, that's okay. So after we check the character, if they did find the character, if we're not at the end of the file table, so the first one will still be the left bracket, but if we're not at the end of the file table, we're going to compare what is in our string here, our file table, to di, the character at di, which is our command string. And since we set it to the beginning, if we entered something like calculator, the first letter would be a C. So if AL is a left bracket compared to C, this is not going to be true, so we're not going to compare. We're going to increment BX to go to the next character up here. So ESBX would point to the C at this point, and then we're going to jump back. So a loop. So if they entered in, calculator, for example, it's a C. We're not at the end. We're here. It'll be a C. And then this in the file table will be a C. So we'll go to start compare right below it. I'm going to save the position in case they type something in that started, started with the C, but they didn't type this right, or this wasn't in the table. Then we'll save the position at BX at this point so we can reload it and continue searching later if this compare doesn't come to fruition, right? So we're moving our command length, which we incremented, should be the length of the input string that the user entered. We're putting that, if it's 1 byte, I might have to change this to a word or something later if they enter in something long, but as long as it's, 1 byte in length for the number, we're going to move it into CL for byte comparisons. If this was CX, I'd probably do like word, but I'm doing CL for simplicity. So we go to compare our compare loop. I'm moving this character back, but it's because I'm incrementing on each iteration of this loop, but we're just moving, the file table character back to AL again. So the first time it's kind of redundant, but that's okay. So AL will be this C. In the file table string, we're going to increment BX, but we won't use that unless we need to compare the next character. We're checking and comparing AL to DI again. So DI is still C, AL is still C. They're equal. But if they weren't equal, we'd go to restart search. But if they are equal, we're going to decrement our counter, which is equal to the length of the string. So this is 10 for calculator is 10 length. So if they found the first letter, then CL will be decremented to 9. And I'm using that as a counter. When CL is 0, that means all the characters have matched at this point, and we'll go to found program, which prints that success message. And you can press any key and you'll go back to the main menu. But if it's not 0, we're going to increment DI, which will go to the next character in our input string. So if it was calculator, it'd be an A. And then we'll go back up, we'll compare the next letter. If this one is an A, then they would match again. Since BX was incremented, this is at the next character, right? And then, we'll compare again, and we'll keep comparing until they enter them all in or they don't match. If they don't match, we'll go to restart search. We'll set DI back to the beginning of the user input string. So if we were at like here, but they typed it wrong and it didn't match, it'd go back to here. DI would. We're going to pop BX so that we get where we stop searching. So if we started searching here, BX was pushed, but they spelled this wrong, or they were trying to search for this and it wasn't right. They pop it back, BX will start here again because we're popping it back. Then we're going to increment because we don't want to count this again because we already did that the first time. So we'll start searching from this point on, say, and then we'll go back to check next character, which is up here, and that's where we check again. If they entered calculator, well, they probably won't find it again, but if they entered program 2, they'll find it. But if you had, multiple programs that were close in name, this would go through, find the mismatch, go back and keep checking until they found it, or didn't find it. So this isn't too bad. It just took me a while to write and debug because I'm not fully used to assembly still, of course, but that's okay. I tried to use some string comparisons, some string operations, but they weren't really working, like scan string byte and store string byte. They just weren't working. I don't know if they weren't incrementing DI correctly or messing with CX correctly or what, but if I do it this full, more manual way, then it seems to work all right. And, as you saw, it'll find the program if you entered it in, and it won't if you don't. So the only thing I have, well, it's a big thing, but the only thing I have left to do is check. Since we can find the program, I need to save BX if it's not already saved, and then I need to get the sector number and then use that to load the correct disk sector to memory and then jump to that to load the program. If the program's already written. If it's not written, then we could jump to an arbitrary point in memory and it would be may be bad. So I might write a small program to load it, whatever sector is available, and then do that. But I'll come back when I do that. Hopefully I sound a little better, not as tired or hoarse, and hopefully I'm not getting sick. We'll see. But yeah, I'll write some code to load the sector and we'll go do that. Just to show again that this works and to have something visual, because it's always better to see something visual. I'll show you again that it works. So since these two are in the file table, these two should work, but anything else won't. So this, you know, it's bad, but program. I think actually this might count if you put something up to the length of the word but not the full thing. I think it'll still find it because it's not checking the full, you know, thing. So I think this will work. Yeah. So even though that's not valid, we don't have good good validation here. It'll still find it, even though we didn't put, you know, the full name. So it'll find program too, right? But it also will find program, which is not great. It'll find prog. It'll probably just find P. Yeah. So that's not great. We'll probably want to change that somehow. But, you know, as far as actually taking in, if they type something and it finds it, we're good. And if they don't, they can keep trying until they do. Or they can press enter and it won't do it. All right. But yeah, that's all this is. Kind of small. It took me a while. Oh, well. But yeah, I'm going to try to write code to load the sector number, and then I'll be back when I do that, because I'm not feeling like debugging that for an hour and having to edit that footage down. So I'll just cut back when I do get that. Might be tomorrow or another day, but that's all right. Okay, so I'm about done with my coffee. That means it's time to record this. I got the old sector number stuff working. I can show you right quick before I explain it, just in case your attention span is the size of a gnat, which mine is, or a goldfish, I guess. So if we put in something that's valid and you actually wrote code at this sector to load, it'll load it. So I have a thing that says, you know, program loaded, and goes back. If not, then you'll find something. So sector not found, I put in a message for that in case the sector's not found, or if the program's not found, which is the same as last time. So we got that. So how do I load the sector and actually load the thing? Well, I got down here starting where, I guess where we ended last at found program. We're getting the sector name after we find it, right? Jump 0, where is that at? Here? Okay. So we increment bx. We incremented up here before, so when we're ending this, do I have the file table open? Let's do that. So where we're ending before, we ended, you know, after it read in all calculator, we increment bx. Since that increments before we jump down here to found, we should be on the hyphen here, character, after whatever program name the user entered. So I'm just going to increment again right when we get there because we want to read the sector number. So we'll be on, you know, the first byte of whatever the sector number is. And to set this up, I'm moving 10 into CL because you need something to multiply by 10. If we're going to read byte by byte, so the best way I read up and saw and did this is getting the first byte into a variable, into a register, multiplying by 10, and then adding, you know, the next byte after you multiplied by 10. So if this is 12, we want to move the 1 into somewhere. We want to multiply it by 10 to get 10, and then we want to add on the 2 so that it'll be 12. And this will work up to, I don't know, however many sectors, I guess. I think the regular int13 to read disk sectors, that int13AH2, only works up to maybe like 64. Well, it uses CL, right? So it would only work up to 8 bits, which would be, I think, 64, right? So up to sector number 64, this should work. Above that, we'll need something else. But, you know, we're adding in the first digit, multiplying by 10, adding the second one, effectively. And that should work for both of these. Well, it at least works for calculator, which is a 0.6. I think it should also work for program too, but I haven't written one of those. I haven't written that yet to load. But anyway, that's why we're moving a 10 into CL, because we're going to multiply the thing by 10. AL is what we're going to try to get the sector number into, so I'm going to reset it to 0 to start off, because for the MUL opcode here, multiply, it multiplies by AL, so you'll see that. So I'm just setting it to 0 to start off with. So to get the sector number, instead of putting it into AL, I'm moving the next byte into DL, just because I need a third, you know, register variable to work with. So DL will be equal to this 0 if we enter in calculator, since we're on the sector number. DL would be 0 in this case. in this example. Going to increment bx just in case, you know, we want to read the second one after. So I'm comparing DL to comma. If we're on the comma, then we're at the end of the sector number. So we have 1, 2 bytes, and then a comma. So if we're there, we don't need to load the sector number. We just need to quit out because we already found it. But if we didn't find the end of the thing at the end of the number, then we won't go to load program here. We'll compare it to 48. Now you can also put, I believe you can also put something like 0 here, because that's what we're comparing to. But I'm putting 48 because why not? 48 and 57 are the numbers that correspond to the ASCII characters for 0 and 9 respectively, and they're in linear order. So 49 would be 1, 50 would be 2, 51 would be 3, so on. So if it's less than 48, then it's not at the start of the numbers in ASCII. It's not at 0, so we're going to go to sector not found because we're not really at a sector number. It could also be they typed in the program wrong. So if you typed in a calcul and then it tried to find a sector, there wouldn't be a sector here, so it would give you that message. So that's kind of a validation check at the moment for if they didn't type in the full program name or they typed it in wrong. It's going to say sector not found. But so we got that. We're also going to compare it to 57, which is the 9 in ASCII. So if it's greater than 57, it's, you know, still not a number. Go to sector not found. I guess we could put like invalid number or something as a message, but oh well. But if it is a valid ASCII number, 0 through 9, 48 through 57, we're going to subtract 48. So subtracting the 0 character in ASCII, because that will give basically the integer equivalent. This is kind of like writing A to I in C, if you're familiar with that. Not quite, but kind of. So if you subtract 48 or you subtract ASCII 0, that'll give you the integer representation. So since the character 0 in ASCII starts at 48, if you subtract 48, the number you'll end up with is 0, which is 0. And then 57 minus 48 is 9. So, you know, you're taking the character 9, turning it into an integer 9. So that's all that's doing there. So the number, our sector number, our bytes of the sector will be in DL at this point. So I'm going to multiply, I'm going to do MULCL, which I think is unsigned multiplication. I think imul is signed, but imul works with 2 operands, and mul works with a 8-bit or 1 byte operand, so that's why I'm using mul, so I can use 8-bit with CL. But mul multiplies your operand that you give it, multiplies it by AL if it's 1 byte, the accumulator, and then it puts the result in AH and AL, or well, in AX effectively. If your 8-bit multiply equals a 16-bit result, then it'll be in AH, the higher 8 bits, and AL, the lower 8 bits of the result. But since we're only working with up to an 8-bit number, it should just be in AL, so we don't have to worry about AH. But that's what this does. That's why we're AL times CL, AL times 10, because we moved 10 to CL. It's multiplying AL, which at this point would be 0, times 10, which would still be 0. And then we're going to add in DL, which is our sector byte. So at this point, yeah, it'd be 0, and AL would be 0. But that's all right. We're going to add DL to AL. Then we're going to get the next number. So the next one would be 6. 6 is not a comma. You know, it's a number, so we get the number, integer 6 into DL. Multiply AL again, which is still 0, because it's 0. But we're going to add 6 to AL. So AL at this point would be the integer 6. Okay, and then, you know, we'll be at a comma, we'll go to load program. So just want to say, if this was at program 2, say we put that in and it's 12, AL would first be, well, DL would be 1, AL would be 0 times 10 is 0, then we'd add 1, so AL would be 1. But then at this point, DL would be 2, CL is still 10, so AL would be 1, right, if we're going to this 12. 1 times 10 is 10, and then we would add 2 to that result. So AL would be 12. So this should still work for, you know, two-digit numbers above 9 up to 64, hopefully. But anyway, if we find, and we get to the comma, we find the sector all right, we'll go to load program down here. If we didn't, you know, we print the not found message. They can enter a Y to restart, or anything but a Y to go back to the main menu. But if they found it, we're going to go to load program, going to move AL into CL, because for our interrupt 13, our AH2, in hex to read disk sectors, CL would be equal to the sector number we want to read at, we want to start reading at. And that's the sector number we want to load our program at. So if it's 6, CL would be 6. We want to read sector 6 to load the program. So I'm going to reset the disk system as good practice before we try to read it. So just AH0, I think DL0 for the drive that you're going to reset. I believe it's the drive. It's the drive or the head or something. I think it's the drive. And then int13 to reset drive 0. which is the only one we're working with. So I want to load our program at an arbitrary point in memory, which means we need an arbitrary memory buffer location. I'm just going to say it's 8,000 for this. I'm just going to use 8,000 for now as the point at which to load our programs going forward. I can change it later though. I probably will. But say we want to load it at 8,000. So I'm moving that into AX and then moving AX into ES and zeroing out BX. So ESBX, our memory buffer, will point to 8,000 with a 0 offset. And then for int13 AH2 to read this sectors, moving 2 into AH and hexadecimal. This could be integer, but I'm still doing hex for all these. The number of sectors to read at the moment, our calculator program that I'm trying out is just less than, or well, it's up to 1 sector. So I'm just reading 1 sector. Track number, I'm doing 0. Head number, I'm doing 0. And drive number, I'm doing 0. And then we call it, and if it worked and loaded, we're going to go to program loaded. The carry flag will not be set. If the carry flag was set, then there was an error loading, and I'm going to print a program not loaded message. But if it was loaded, we're going to go to program loaded, which just moves 8,000 back to AX, and then kind of resets all the stack segments to 8,000, so that memory is set up all right. And then we're going to far jump to 8,000, which since the program has been loaded to memory location 8,000, when we jump to it with the 8,000 with the 0 offset, when we jump to it as a far jump, the code segment will be moved, the instruction pointer will be moved, and we'll start reading at this point in memory, which effectively is where our program's loaded, so our program will start executing. And after that, it's whatever your program does. So I have set up basic. So in my calculator program, I have to include these files again because they're not pointed to in memory. It can't see them, so I have to include them again to whatever program I want to use them. So for the calculator that I'm loading, which doesn't do anything, all it does is reset the screen and print, our test message here that I set up. Program loaded, so it displays program loaded after resetting the screen, a text screen, and then it takes any keystroke, and then it jumps back to the kernel. So I do the same thing here to set up memory location 8,000 to jump to our program that we loaded to memory location 8,000. I'm just setting up 2,000 because our kernel is set up and loaded at memory 2,000. So I'm just setting that up and far jumping back, which effectively loads, starts back here and loads our kernel again. Our main menu and all. So it's actually not that bad. It was a bit better than I thought it would be. Just setting them up and loading. My brain had a good bit up here. I was like, how do I get the 1 byte in there? Okay, you can just multiply by 10 and then add it. And I was like, okay, that makes sense. That was pretty easy. But yeah, that's all the calculator is doing. So the 2 messages I added down here. Not loaded, program not loaded message, the not found string, the sector not found. That's all I added down here. The calculator, I don't know if I have to pad this out to 1 sector, but I figure I would, so there's not arbitrary values in here. Pad it all out to 0s just to be safe. But yeah, so the only other thing I did with that, if I still have this buffer, is I changed the make file to add calculator, because at the moment I don't have anything running within the OS to write machine code, write bytes or whatever to our disk that it's running from. So I had to add this onto the os.bin to get it to load to sector 6. So since our kernel here is padded out 3 sectors, our boot sector is in sector 1, our file table is in sector 2, the kernel is padded out to 3 sectors, which would be up to sector 5. So if I put the calculator right after and concatenate it onto the end, and our calculator's padded out 1 sector, it'll be sector 6 at the end. And then I just added it here, doing the same thing, running FASM to make it a binary, and then moving the binary, and then concatenating it into our os.bin. So that is all I'm doing there. So if I do make clean and make OS, like I just did before I started recording, it works. And again, we can run box. And a program won't be found, sector's not found. If we type in something completely wrong, the program's not going to be found. But our calculator is valid and it will be found and loaded at sector 6, which all it does is print the program loaded message. So I can work from here and load, any whatever program we want to load now. So we're getting somewhere. Again, still slow going, but we're getting there slowly. I think the next thing I want to do is, I can flesh out the calculator a little bit and have it take in arbitrary math operations and run them So I will either do that, or I may start on like a little text editor type thing. So I want to like reset the screen, have it set up, not like Vi or anything, you know, more complex, just real basic text editor that has the ability to write bytes to the disk. So I want to have it write bytes to the disk and then update the file table and add on to the end of it. That way, if we go back to the main menu and we go to the file browser, we'll be able to see that program that we would write, and then we'll be able to load it. So at that point, I think technically our OS would be kind of self-sufficient. So I want to try to move towards that. Then I can write and edit the OS within itself, and then we won't need to use like this Ubuntu VM, which I've had this bar up here the whole time, sorry. I won't need to use that. I can use, you know, the OS from itself on bare metal or something. So that'll be cool. I can do a bare metal test and see how that works. Fix any bugs that arise from that, because this is just using an ideal x86 emulator. So, but yeah, just wanted to show that's how you load, you know, sector numbers from the thing. Pretty sweet. And yeah, hopefully it's not too hard to understand. It was for me for a bit, but you know, I work at things slowly till I understand them and try to explain them. But yeah, hopefully you enjoyed that and you're not too bored on my monotone voice in the morning, but good old 7 a.m. But yeah, hopefully you like that. I will see you guys on the next one. Thanks for watching.